This is the first video in a series about reverse engineering in Creo parametric, and I will be showing you how to use Creo to reverse engineer, and I'm also going to try to explain how to what the basic principles of reverse engineering. And before I start, I would like to say that I am largely self-taught, so I try to find things on the internet, and I just try things and see if they work. So I recommend that you also do that same thing when you come to some kind of problem. And because of this, I don't know a lot of things. I have ways of how I do them, but there are probably better ways of how they can be done. So if you know how to do something better, please let me know in the comments. I will be happy to check it out and improve myself. Okay, so the first one that we are going to do is quite a simple one. So it's this kind of pulley, and it's simple because it's nice and symmetric mostly, and you can do it basically with a single revolve feature and then a few extrudes. And I'm going to link also these pictures to you, so you can download them and check them out, so you can see what you have, what the object that you are actually doing. And often it is like this: you have only some pictures of your object that you are reverse engineering, or sometimes not even that. So you have to just see what you have to look at the 3D scan and figure it out. So this is the pulley, and so here is a top view or side view, and here is one feature that we're going to be working with. And you can see that the diameter of this hole has been reduced, and this is the first lesson of reverse engineering. If you can simplify a model, simplify it. So in this case here, we're going to say that we don't need this large diameter, we only need this small diameter. So when we are going to be making a model of it, where we are not making this separate small tube in the pulley. It's all just going to be one solid model, but we'll come to that later. Okay, so if we go to Creo, the first thing that you should do is change the settings a little bit. So you can go to File and Options, and here go to Sketcher and scroll down, and here there is an option, Allow Snapping to Model Geometry. So usually the traditional way in Creo is that if you want to use an existing geometry in your sketch, you have to create references. But this option here removes the need of references, because you can just draw directly from, you can reference your geometry directly to existing whatever geometry you have there. But that is not so good for us, because it will try to snap all the time on the points of the 3D scan. So it's almost impossible to work if you have this thing on. So just deselect it. Sorry about that. And okay. And if you are working on your own computer, you can save these settings to so you will always have, so this will always be off whenever you are working. If you are working in school or some computer that isn't yours, then you shouldn't be saving this. But if you are working on your own computer, you can say yes here, and now it's going to ask you where you want to save these settings. And this is why it's important that you do this before you do anything else, because if you save this here in this works folder, now this will be like this anytime when you start it. If you have already set your working directory to something else, you won't have that this setting off when you start it the next time. So if you have changed it already, either change it back to this works, or maybe it's best if you just turn off Creo and start it again and then save this. So I'm just going to save it, and now we have it off. So now I'm going to set my working directory, and so wherever you are working, and I'm going to start a new file or new module, and just normal part. So now when you come here, now first thing you have to do is you have to import your 3D scan. So you do that by going here to get data, and you click import, and I have my STL here, and I'm going to also put a link of this STL in the description of this video so you can get it there. And so you select it and just import, and here is this import dialog window, and you can deselect this generate log file because it will just create a text file in your working directory that you don't need. Okay, so when you see the model here, you just confirm here on the tick. And right now you see this is not very useful, it's just dark, and well, actually in this case we can see quite okay what it is, but I usually work with shading, because when you have shading with edges, all these triangles that your scan is made out of, after you polygonize it, will show the edges. So when you are zoomed out, you just see black. But if you have the shading option on, it's you just see the model pretty well how it should be. And so you can see here that we have quite an incomplete scan, and this was intentional. I scanned it like this intentionally because I wanted to show you that you don't need a complete scan. You can have plenty of holes inside it, as long as you have the features that you need. So for example, this the basic geometry is going to be created with one revolve. So all we need to do for that is like one cross section. So we don't need any of this missing geometry here. So remember, if you are scanning, don't be too worried if you don't get every little piece of your model. Just focus on the things that you need to reverse engineer the model. And so of course first you can already plan your procedure of reverse engineering while you are 3D scanning. And before we start reverse engineering, let's do one more thing. So right now this model is gray, and unless you change your default color, also what you are modeling the solid geometry is going to be gray, and it can be sometimes a bit bothering because you might not be sure what is what. So we're going to change the color of this. And how you do that is you go here to surfaces, open the drop down and click restyle, and now you can just say cancel, and now we have a different color. So this restyle is a reverse engineering tool in Creo, which I'm not going to go into right now because it's not really useful for us. So for now I'm just going to use the coloring feature of it. So when you just open restyle, it will color it automatically because it knows you are trying to reverse engineer. And if it happens that you click this and nothing happens, this it's waiting for you to click on the model. So I'm not sure why. Sometimes it works and sometimes it doesn't. But if you go here, click restyle, and nothing happens, just click on the model and it will then it will work. Right now I can't show you because it's working for me automatically right now. So, but you will see it how it goes. And now this, you can just delete this restyle that was created because it doesn't serve any purpose. You still keep this color. Okay, so we have the default planes, and what we're going to do now, we are going to make a cross section, and then we're going to use that cross section to make a solid body. And we want to make a cross section here where we have a complete scan through the whole body, so in this direction. And to create a cross section we need a plane. So right now we don't have a plane going through there, so we have to create one. So if we show also the axis, we are going to create a new plane. So by holding the control button, click on this axis, and now click on, so either this plane or this plane, it doesn't matter which one. Okay, and so for the axis we have the true option, and for the plane we have the offset, and this offset in this case is going to be measured in degrees. So right now we have 45 degrees, and if we look like this directly down along the plane, we see it's quite okay. Maybe it's a little bit better if it goes a bit more up. So if let's say we put here 40, let's see how that looks. Yeah, that looks quite good. So we have a complete geometry through here. So we just say okay here. And now we have to create cross-section view first. So we go here to view and section and planar, and now select this plane that we created, and it doesn't matter now in which direction we are looking because we don't actually need this cross section. We only need the cross section to create we have to create the cross section view so we can create the cross section. So we can just confirm this, and now open here the sections. Yeah. So this is the cross section view that we have created. We can turn it off now, and right click on it and select curve from cross section. Okay, so now we have a curve going uh, along here. So everywhere where this plane intersects the scan, there is a line. And let's maybe hide the planes and the axis. So now we're going to create a revolve using a sketch that we are going to draw using this cross section curve. So we're going to create first a sketch on this datum plane that we created. So on this datum plane, let's go to sketch, and I like to use I recommend that you use this not that you go directly to revolve or extrude, but that you first create a sketch and then do that, because it sometimes happens that you might have some problems. You have to maybe create something new outside of the sketch, and if you are using this, you will have to just delete that sketch and start over. But if you are using just sketch like this, you can leave that sketch half finished and then restart again. So let's make a sketch here, and now this scan is in our way. So if we go to this view, and I'll just make a horizontal reference here, so, and maybe section orientation, yeah. So this is how it feels natural to me. So this is just not necessary, but I like to do it. So right now, so we can see this curve here, but it's a little bit obstructed by the scan, so we're going to hide it. So you can just right click on here, facet feature. So facet feature is our scan, and say hide, and now all we have here is this curve. Now the first thing that we have to do is create references, and we're going to be drawing only straight lines, so we need only 2 references per line. And well, we start here. This one we can skip because we have the original, this coordinate system already, but then we can go here, here. Here we have this curve, but we'll start with lines and then just put in rounds to fix it. Okay, that is all that we need for now, and so I made it only on this half because the pulley is symmetric, at least in this. The main feature is symmetric, so we'll only need to make half and then mirror it on the other side. And now we can just go to line and draw lines between these reference points, but make sure that after every time you confirm it with the middle button, so you are not dragging all around. So just make these short lines between the reference points. Okay. Oh, actually I forgot one here. And now we have to join these lines together, and we do that with corner. So this will extend the lines until they meet each other, or until they intersect and create a corner out of it. Okay, so like this. You just go all around. Okay, and now these lines are following the original curve pretty closely, but we are not going to leave it like that, because what the model that we are trying to create, we are creating for manufacturing, and because of that we want all the lines to be in regular geometric relations. And for example, we want these lines here to be exactly vertical, and these here, here to be horizontal, because now if you look closely, this one should be vertical, but it's not vertical, because these two reference points aren't exactly on a vertical line. And now to do this, we have to first delete these references, because if we want to, for example, if I say I will change this line to vertical now, oh, actually it worked. Let's see. Okay, that's a bit strange. So it automatically deleted the reference. I don't know how come this happened, but yeah, I'm going to leave this part in the video, because just so I can show you that sometimes unexpected things happen. But yeah, I'll ignore that this actually works right now, because usually it doesn't work. And so I'm just going to undo. And so how I would usually do it, I would now delete these references first, and you do that. The easiest way to do that is to go here to, this is the selection filter, and you can just select here constraint, and now you can just select, so like this, you can select, and this will select only the references, it won't select the lines, because here you have that only the constraints can be selected, and now you can just delete them with the delete button. But when you are doing that, it's good that you leave one reference here, at least one. Well, here, so there are two, because it's attached to this line and to this line. But so it's good if it's attached at some point, because otherwise, when you are changing these dimensions or putting other constraints, the sketch might run away from you somewhere. So it's good if you leave it attached somewhere. So, and now we start putting the constraints in, and if we start with vertical, so we just say which ones, and that's it. Well, this one is already vertical, and now let's go to horizontal. And next we can take coincident. So these two lines have to be on the same line. And these two same. And this one and this one have to be parallel. This. And anything else? No, that's it. And now we can start fixing the dimensions. So the dimensions right now are a little bit off. So for example, here we have 23.49, or actually if I open it up, you can see here there's like 10 decimal numbers. This is because when you manufacture a part, there's always a little bit of a difference in the dimensions from what you planned because of the manufacturing tolerances. And then also when you are scanning, there is some imperfection in the scan, so you get this kind of number. But what we are trying to do is now we try to change these numbers into something that makes sense, because when you are manufacturing, you don't want to use this kind of number, especially if you are making something on manual machines, which is not common, but still we should keep to those principles. So this is 23.48, 23.5 seems quite obvious value. And for example, if we go here, so this is a little bit more off, but if I would say 43.5 would be quite okay. So you see it's a little bit off, but if you zoom out, it basically looks the same. And also it's good if you are somewhere in between and you don't know what to put, try to put a number that will reinforce your product. So here I could put 43, for example. It wouldn't make any much difference right now, but you see here your product that you will manufacture is a little bit smaller, a little bit skinnier as the original, and if you are not doing new calculations, you can't be sure if that is okay or not. So it's better to make it a little bit stronger than weaker if you are somewhere in between. So let's go forward here. I'm going to round it down because this is now anyway, they are not straight lines, and this is not like any kind of important measurement. Let's take the outside diameter, 85.10. Well, 85 I think should be okay. This one, let's put it to 18. So here I rounded down, but as you can see, it reinforced the material. Basically, you added a few like 0.5 millimeters. Yeah, it doesn't really make much difference, but yeah, it's good to add material, not take it away. So this can go to 20 maybe, and then here we pull this one a little bit to the right, so we should increase this number 4.5, and let's take these angles first. So how is it, 107, and oh yeah, so here it is, the other one, 107. Yeah, and let's say here, how would it look like? 5, no, 5.5. Yeah, it's also a bit off, so maybe here I would put 5.25, because this is there's going to be a belt fitting inside here, so there is likely that there is some kind of quite precise measurement. And I would recommend that whenever you are doing something with some standard, so this is a standard part because there is a standard belt fitting in, so it's always good if you find the standard and put the standard dimensions in. I'm going to guess right now, but yeah, if this would be a real product, it would be better if you check what are the standard dimensions. And then here we need 5.25 divided by 2 because then we're going to put the mirror line here. This one 1.5 maybe. Well, let's see how it looks like after we make the mirror, because now it's also a little bit off, but let's see how it goes. And let's take this one. So it was a little bit up, so let's say what's 71.5. Yeah, that looks pretty close. Okay, now we have all the dimensions, and generally in any kind of modeling you try to avoid putting chamfers and fillets in the sketch, but in reverse engineering I sometimes use it because it's easier in the sketch to fit the lines to the curve, because you can see more easily how it fits. So I'm going to do this part here now in the sketch, but then the others, so here and up here, this I'm going to do afterwards with rounds. So let's put fillets here, and now you can see here why it's another reason why it's a bad idea to put rounds in the sketch. It deletes all these dimensions that you have defined before. So this 18 was defined before, but now it became undefined. So basically this, oh, so now this is movable here. So you have to be careful with that. So if you add some rounds inside here, make sure that the first thing you do is redefine these dimensions that you have defined before already. And so same with this up here. So from here to the original crossing point 13.5, okay, and from this crossing point, yeah, to the top. What did we have before? Was it 19? Okay, maybe 19. Yeah, looks about right. Oh, and this one also. 24. 23.5. Oh. Maybe 23.5. I forgot what I was using before, but you get the idea. So here we have to increase the radius, let's say 10. Yeah, looks about right. So here maybe same, and then here 5, maybe 4, maybe 4. And so these aren't functional dimensions, so it doesn't matter so much. Just it's good if you try to make it look pretty much the same as what it was originally, but yeah, if it's a bit off, it doesn't matter so much. It's this is yeah, more about just the looks and the ease of production, then it doesn't serve any direct function. So now we can create a mirror line. And select what you've done and click mirror, select the line, and we get the mirrored side. And also here it looks okay, it's all following pretty nicely. Here it's a little bit off for some reason, I'm not sure why, but yeah, this is not so important here, so this is a little bit off. And so now we just have to connect here, and we have a complete sketch. And the last thing before we finish this, we have to draw a center line for the revolve. So for when you are mirroring, you are using this center line. When you are doing revolve, you are using this center line. So this is for sketch only, and this is this goes out also, so you can use this afterwards as an axis. And so this is now the sketch is complete. You can confirm, and let's go to revolve, and here you have it. We have the basic shape ready. Okay, and now we can, or actually we can still keep this curve for now, because we have to put the rounds in. So here and on the other side, so now hold Control to select the other side also. So now you can compare it to the original cross section. So you can see here that now the radius is maybe a little bit too big. So let's try 3. Yeah, it's pretty close, I think. Yeah, also, well, yeah, here we have some discrepancy now, but let's try to aim it on this side. And now we have to do also here. And now if you want to start another set, so don't hold Control, just click on the line, and you can see here it started a new set. And now on this side it's going to be the same radius, so hold Control and click here on the other side. And this is now quite a lot too much, so maybe 1 millimeter. So actually what you can also do is now you can show the scan again and compare to the scan. So just right click here on the facet feature and show. Okay, it's not showing them. Why is it not showing them? Okay, I'm not sure why it wasn't showing. So now you can also compare to the original scan a little bit. So it's maybe not here the overlap is not so great, so but I think this 1 millimeter would be quite okay for this. And now we have to do, we have to do also here. So now don't hold anything, or actually it starts on this side already. Don't hold anything, just click here. So you can see a new set starts, and now hold Control and select the rest of these edges. And here one is going to be a bit too much, so let's see 0.5. How does that look? Yeah, that looks quite okay, I think, because it shouldn't be, there shouldn't be too much of a ground. yeah, this looks good. And the insides also. So again, you don't hold anything, just click, and now hold Control and select the rest of the edges. And maybe here, see how does it look like. Maybe here we can try with one. Yeah, maybe it looks quite okay, I think. And I think that's it what we need for now. Yeah. So you can just confirm. And let's hide this one again. And now you can hide the curve because we don't need it anymore. So we just hide here. Oh. Okay, so this is what we have so far. So it's the basic form of the pulley. And now let's show this one again. So the next thing is this hole that is going through, and like I was saying already before in the beginning, let's go back to this picture. Yeah, so you can see first there was this larger diameter, and at one point they reduced it to this smaller diameter, and so that's why now we're going to ignore this large diameter and only create this small one, because we don't need the large one. And for this I actually have the standard here. I'll also attach this, so because this is more important that it's exactly the correct fit, because yeah, otherwise the connection won't work correct well if you don't put all the exact numbers and exact tolerances. So what we're going to do now is we first need to measure this diameter of this hole if we want to use this table, because you can see here we have the diameter of the hole. So to do that we are going to have to create another cross section, and if we would do it right now we would get both the original scan and this thing that we have created, and that's why we have to roll back the model here with the insert here. So you can just pull it up in front of the Revolve, and now we again have only the scan. And so now we want to create a cross section that is going something like this here. So we are going to get a curve that is going to be going through this part that we have scanned. So we're going to be using this plane. Go to View and Section, and now just drag this. So you can just drag this. So this is your starting plane, but then you have an offset here, so you can just drag it around to get the correct distance. And this is quite okay. Yeah, this is pretty good, because so now we are going to get a curve of this hole and this hole, the round hole and the slot for the key. So we can just confirm this. And for some reason when you have the cross section views with the facet feature, there is something weird happening here, so you can't see through. yeah, I don't know why this bug happens, but yeah, just so you know why this is appearing like this, a bit strange. So just go now, same as before, go here to the sections, and this is the section that we created right now. Right click and curve from cross section, and now you can just deactivate this cross section and hide the facet feature. So hide. Okay, so this here we have what we needed. So now we're going to create a sketch out of this, and we can just do it on this right plane. So the actual cross section is, so the cross section is a little bit off from this right plane, but it's on a plane that is parallel to the right plane, and then when we come to the sketch, we are going to create references anyway, so we don't have to draw on that plane where the actual cross section curve is lying. So we can just start a new sketch here, and view, and we can hide the planes now. And now, so first thing, we create the references, and we're going to be making a circle now, and to create a circle you need 3 points, so we create 3 references like that. And for the slot, actually we don't need to do it right now, because when I was aligning this scan, I already aligned it like that the slot is exactly centered to the one of the planes, and that's why we can then just ignore this and just draw everything from this, like by the instruction of this standard. So now we have the references for the circle, so we can just go to the circle and 3-point circle and draw it. And now the problem is, in Creo 4, for some reason, when you are doing circles, it doesn't show the all the references that you have used, so it only shows one. And so because of that, we can't use the same method as before to delete the references, so that we will go here, or to delete the constraints and select constraints and delete them, because so now this circle is constrained here, but we can't, it's not showing it. And to solve that problem, you can just go here to references and delete these references that you have created before, and delete, close. And why we have to do that is this circle now is not exactly here in the center, because yeah, it's everything is a little bit off, so we have to fix that. So we can just say coincident, select the center and select the vertical line and select the horizontal line. So now it's exactly centered, and now the only thing that is still free is the diameter. And so the diameter is 30.04 and so on, so obviously this would be 30. And now this circle is fully constrained. And now we can go to the standard and go here. So we have if the diameter is 30 to 38, the width of this slot is, so where are we here, is 10, and the height of the key is 8, but then the here, so the distance from the opposite side of the circle to the other end of the slot has to be d plus t2. So in our case that's 3.3. So the distance has to be 33.3. So we can go back here and create a rectangle, and let's take center rectangle maybe, so we can right away attach it here to the center is going to be on the vertical line, and let's just say, so you can just put it anywhere here right now. And now take the dimensions, and was it 10? So yeah, 10 is the width, and then the distance between here to, is it going to work like this? Yeah, it will, is 33.3. So diameter is 30 plus this dimension T2, here you have it explained. So it's T2, it's 3.3, so 33.3. Okay, and now all we have to do is delete these extra lines here. So we can just go to delete segment and delete the extra lines. Okay, and now the sketch is complete. So we can just accept the sketch, and now we have to extrude this sketch out of the original or the revolve that we have created before. So first thing, we can just delete, not delete, but hide this curve, and now we roll forward on the model. So we have this, so we have the sketch and we have the revolve. Select the sketch, go to extrude, delete material, reverse direction, and select through all, and check if it looks right. It goes through, so just accept that. Okay, so now we have, basically now our pulley would be already, I would call it complete already. But if you look at the scan, let's roll it back, you will see it has these 3 holes here, and I'm not exactly sure what this what the purpose of this is, but my guess is it's to grab it. So when I was carrying this around, it was pretty heavy, but my fingers fit into this pretty well. So my guess was that this is just for carrying it around. So we are going to also create this. And let's show the planes again. So what we need to do is we have to create a cross section of this so we can get the dimensions. So we're going to create another plane that is going through that, same as we created this first plane. So we have to also show the axis, and we create a new plane. We can select this axis and this plane, and again you have to hold control so you can select both. And now if we change the view to right, yep, and maybe let's put shading. Oh, and we're going to use this hole here because it's the most complete, so it has also this, and on all sides everything is complete. Right, and now let's pull it into position approximately, something like this, maybe a little bit back. Maybe this is about right. Yeah, well, this angle doesn't matter really so much, so you can confirm that. And now go to view section and confirm this, and create curve from cross section, and deactivate the cross section view. And now we can hide the facet feature and start a new sketch on this plane that we have created. And so model, sketch, and view, and we can hide those, or actually we should keep this one. So references, we can take that center line, and now let's take this one, and then here. So we're going to make a revolve with the center line here, but now I'm going to make both of these lines here just as a middle step. So I can close this and create lines here through this reference point. Oh, last one didn't stick. Okay, and put corners in. Yeah, and let's delete the constraints, or let's leave on. No, I'll delete all of them right now. So all sketcher here, I think we've put 43.5 if I'm not mistaken. Let's try. We can, or maybe it's best if I go check back. And so now this is what I was talking about before. It's good if you if you just go to pure sketch, not to extrude sketch. So now I can just confirm this, and it's just saved as a normal sketch, and I can go to the first sketch and put this one. So let's see, what do we have here? Where is that? Oh, here, yeah, 43.5. Yeah. So let's go back to this sketch. So 43.5 there, and now let's put these angles in. So I don't know, 128 and 105 here. Or actually, let's undo this. Let's first put vertical here and horizontal for these 2 points here, and now let's put an angle between this line and this line here. Is that going to be, so it has to be 180 minus 128, so 52. And now actually you can see what happens when you delete all your references. This is moving around. So what I should do now is put this dimension in. So 23.5 maybe. Yeah, looks quite okay. No. Undo. Yeah. What's next? So next we should put the fillet here and B5 again. What happened with this one? I guess that fillet somehow. $23.5. Yeah. And 5 looks maybe a little bit too much. Let's put 4. And see how this look is 23. No. 23.25. Yeah, this looks better. And let's move this one a bit down. Yep. Okay, yeah, that now looks pretty okay. So now I can put a center line for the revolve here and delete segment. So I delete everything on the left side because it's extra, and now I just close this sketch. And so I put this extra one, the extension here, just random length. The important thing is that it's higher as this one, because that's it will have to cut something on top. And so let's see how this looks like. So we have the sketch selected. Oh, actually we have to roll down, select the sketch and revolve and cut material. Yep, looks okay. So accept that, and now go to round. This is now so sharp, we should round it up a little bit. And this is now a little bit funny, but let's see how it goes when we go all around. Yeah, it's not too nice, doesn't look too nice. Let's see what we can do about it. Let's accept, let's see how it looks like. Actually, I'm okay with this. It's not any kind of important feature, so as long as it's not sharp, it's okay. So maybe I can just hide this curve, and now we just need to pattern this there are going to be 3 of these. So we have to make a group out of these, and now go to select the group, go to pattern, select axis, and this is the axis. So if I remember right, we have to go in the other direction. Let's put shading with edges. Yeah, so we have to change the direction. We have 3 instances, and for the angle, I am guessing here, let's say 10. Oh no, that's way too little. And let's put here right view 20. Looks quite okay. Let's put 22. 22.5 maybe. Maybe 22. Let's try. Maybe a little bit less. So let's edit this and say 21. Yeah, I think this is pretty okay. And that was the last thing that we needed to do, the last feature. So if we hide the facet, we have the whole thing ready. So here, let's hide this one also. So here it is. So this is now ready for manufacturing. The only thing is that you would still have to do is when you are making the drawing, put the appropriate tolerances here that you can find from this table, but that I'm not going into drawings right now. So this is all for now, and if you have any questions, feel free to ask and I'm going to try my best to answer. And if you have suggestions about how I can do things better, I will be happy to try it out, so you can just write it in the comments.